Okay, hopefully I've got my settings right this time. We're continuing with this January 11th Unit 5 paper. Question 1C, consider the following lattice dissociation enthalpies, enthalpy data. And you've got in the table, just let me switch on my pen and let's go for nice blue. Now, if we look at our data, we've got experimental and theoretical enthalpies of dissociation. And as I'm reading this, kind of things I pick up on is that these two numbers are pretty much the same, while the one for silver bromide here, so sodium bromides are quite similar, and silver bromides are very different. The values for delta HL experimental have been determined from Born-Haber cycles. The value theoretical have been determined by calculation using a perfect ionic model. And the first question is explain the meaning of the perfect ionic model. So what we can say about the perfect ionic model is that the ions that we're looking at are either perfect spheres or the point charges. I'm not going to go into the physics of what we mean by point charges. It's a really interesting concept. But so the first marker for saying that ions are perfect spheres are point charges, and that they only have within them ionic bonding nature. You can say the ionic bonding nature. It's all just electrostatic forces. So either you can write for the second mark ionic bonding nature, or it involves electrostatic charges only. And what we mean by that is that there's no covalent nature, there's no sharing of orbitals, no sharing of electrons, no merging of orbitals, that kind of thing. 1C2, state what you can deduce about the bonding in sodium bromide from the table shown. Well, what we can look at is if we look at NABR, if we look at sodium bromide here, because as I said at the start of the video, they're very, very similar. So what we can say is sodium bromide shows ionic bonding, and only ionic bonding. Actually, I should really say it only shows ionic bonding. Only shows ionic bonding. Okay, let's just switch this pen off and scroll down, and hopefully we can kind of look at both. 1C2 says state what you can deduce about the bonding in silver bromide from the data in the table. And putting the pen back on, if we look at this is the silver bromide here, the numbers are quite different. So what we can say is there's some covalent character, and in essence the ions are not perfect spheres, they're distorted, and so there's some kind of sharing, some kind of covalent nature. There's some covalent nature in the bond. Okay. Let's see if my audio is in sync. Pen off, and here we go.